Okay, so let's look at page 5 in our note packet. We're talking about the unit circle with coterminal angles. Okay, so this is section 7.3 here. And we've got a different representation of the unit circle. Okay, so I'm going to start by filling in quadrant 1. This is originally how I've memorized it. I know that every single fraction here is going to be over 2. And then I know the top of the fractions are either 1 square root of 2 or the square root of 3. So to help me memorize this, I just always know it starts going 1, root 2, root 3, kind of counting like that. Oops. And then we've got the opposite. So then it just flips. We go 3, 2, 1. So there's root 3 over 2. Here's root 2 over 2. And there's 1. Okay, so if we notice here in quadrant 1, everything's positive, positive. I'm going to look at quadrant 2. Since my x-coordinates are negative, y is positive. Oops, I'll write that over here. Okay, in quadrant 3, x is negative, y is negative. And in quadrant 4, x is positive, but y is negative. So today, to kind of give you a different visual representation, we're going to draw rectangles to connect a point in each quadrant that has the same coordinates. So you're going to see the same values, those same numbers, just with different signs on the unit circle. Okay, so here, if I connect the dots that are the closest to the x-axis, okay, these points are all 30 degrees away from the x-axis. Okay, so here, this is for 30 degrees. Here, if I've rotated 30 degrees less than this 180, that's at that 150. And your point is those same values, just different signs. So we've got a negative x and a positive y. Okay, here I'm 30 degrees more than 180, so that's how we get that 210 degrees. And both x and y coordinates are negative. So remember, it might seem kind of pointless right now, okay, but in those future math classes, this is something that you have to have memorized. The more you can start to see these patterns and realize that as long as you just have quadrant 1 memorized, the rest would be easy to fill in, that'll help you be able to draw this whole thing. Okay, originally, our plans for AMS 2, you would get a quiz and the first couple problems were just asking you to fill this thing out entirely. Okay, so you're going to have to do that in your future math classes. So here I was 30 degrees less than, this is 360 if I rotate all the way around, so that makes it 330. And both of those x and y coordinates are negative. So I have a negative root 3 over 2 and a negative 1/2. Okay, looking at this root 2 over 2, kind of in the middle of each quadrant, drawing a nice rectangle to those points there. Okay, these are all 45-degree angles. If we drew in the radius, it would make a 45-degree angle with the x-axis. So if I'm 45 degrees short of 180, that's 135 degrees, with a negative root 2 over 2, then positive root 2 over 2. Okay, now in quadrant 3, I've rotated 45 degrees more than 180, so 225 degrees. And now both x and y are negative. So negative root 2 over 2, negative root 2 over 2. Here I'm 45 degrees less than 360, making that 315 degrees for the rotation, landing us at the point positive root 2 over 2 and then negative root 2 over 2. Okay, so I see an error here where I said that this was negative root 3 over 2. It can't be negative if it's in quadrant 4. X values are positive, Y values are negative. Okay, and then our last one here, if we're looking at this spot here, this was a rotation of 60 degrees. I'm going to make that rectangle to all of those spots. Okay, so here I'm 60 degrees less than 180, making that 120 degrees for the rotation. And now it's a negative x value, negative 1/2, and a positive x value, root 3 over 2. Positive root 3 over 2. All right. Then in quadrant 3, we've rotated 60 degrees more than 180, making that 240 degrees here. And that puts us at negative 1/2, negative root 3 over 2. Now in quadrant 4, I'm rotating 60 degrees less than 360, so I've rotated 300 degrees. And that lands us with a positive x value, positive 1/2, and then a negative y value, negative root 3 over 2. Okay, and then the last thing that we're missing here are just the multiples of 90. So we started with 0 or 360. Here, if we've rotated 90 degrees, that's at the point 0, 1. This was a 90 degrees. Okay, if we rotate 180 degrees, that's at the point negative 1, 0. And another 90 makes this 270 degrees. And that's at the point 0, negative 1. Okay, so we've filled in this unit circle again. Maybe it helped today to kind of see those rectangles on there, see how we have those same signs, or sorry, same values but different signs. Really just start looking for those patterns to help you memorize this in a future math class. Today we're talking specifically about coterminal angles. So these are going to be two angles that are 360 degrees times n apart. So n is going to be some integers. So the angles are separated by a multiple of 360. So if we see angles that are bigger than 360, okay, that just means you went more than once around the unit circle. So you're going to keep subtracting 360 degrees until you get an angle value between 0 and 360, and then find on the unit circle. We're going to see negative angles today, negative rotations. So we're going to keep adding 360 degrees until the angle value is between 0 and 360. Between 0 and 360 are on the unit circle, so then we'd be able to find it. Okay, so I've got our unit circle on here handy for us to look at. Okay, so if I'm looking at the sine of 660 degrees, okay, that's not one of my angle measures right now. We can't find that rotation on the unit circle since that only goes from 0 to 360. So all we have to do, since it's bigger than 360, is subtract 360. We're really looking for the sine of 300 degrees. Now, on our unit circle, let's figure out where a rotation of 300 degrees lands us. So I see it down here in quadrant 3, 1/2, and negative root 3 over 2. And remember, sine is just that y value. Okay, we'll do the same thing with the cosine of 495. Start by subtracting 360. So we're looking for the cosine of 135 degrees. Okay, if we find a rotation of 135, that lands us at, I'm going to put it over here, negative root 2 over 2 and positive root 2 over 2. And since it's cosine, we're looking at that x value, so just the negative root 2 over 2. Then we have the sine of 570. So subtracting 360, we end up with the sine of 210 degrees. Find a rotation of 210 down here in quadrant 3. We're using the ordered pair, negative root 3 over 2, and then negative 1/2. And sine is just the y value. So the sine of 570 is really negative 1/2. And if we're looking for the cosine of a negative 45 degrees, there's no negative rotations on here. Okay, a negative rotation would mean that you would start here and go counterclockwise. I'm sorry, that's clockwise. So if you could handle that, think of a rotation 45 degrees clockwise, you would know that that's really the same as 315. Otherwise, you can always just add 360 degrees. We're looking for the cosine of 315. If we rotated 315 degrees, it lands us at root 2 over 2, negative root 2 over 2. And cosine's just the x value. So we get, oh golly, we get a, oh, okay, this is messy. We just get root 2 over 2 there. Okay, so now, same thing here. Sine of 210, right? That one's already on the unit circle. So just figure out the rotation of 210 lands us at negative root 3 over 2, negative 1/2. And sine is our y value, so negative 1/2. Tangent problems usually require some work. Okay, since this is negative, there's no negative rotations on here. You could think of that rotating clockwise 60 degrees, so that would put you at 300, or just add 360. So we're trying to find the tangent of 300 degrees. Okay, I'm going to scoot this over here for a sec. When I do the tangent, I have to take the sine and divide it by the cosine. So when I look at where 300 degrees, that rotation lands us at 1/2, negative root 3 over 2. I have to take that y value, my sine value, and divide it by my cosine value, divided by x. Instead of dividing by a fraction, we're going to multiply by the reciprocal. So we end up with negative 2 root 3 on the top over 2. And I can reduce this fraction. Negative 2 divided by 2 would give us negative 1 times that root 3. So when we asked for the tangent of negative 60, that really was negative root 3. Okay, sine of negative 660. Let's go ahead and add 360 to that. That gives us the sine of negative 300. Since it's still negative, we need to add another 360. End up with the sine of 60. Okay, if we rotated 60 degrees, that lands us at 1/2 and root 3 over 2. And our sine value is that y coordinate. So we would say here just root 3 over 2. And we've got the cosine of negative 855. So we're going to have to add 360 a couple times there. So really, if you wanted to do 360 times 3, we'd end up with adding 1,080 degrees. We're just going to keep adding 360. Then it ends up being the same as the cosine of 225. So if I rotate 225 degrees, I see we're at negative root 2, negative root 2. And cosine is just that x-coordinate. So we'll just say negative root 2 over 2 for our final answer. Okay, so here we have the tangent of 765. I'm going to have to subtract off 2 rotations of 360, which will be 720. So we're looking at the tangent of 45 degrees. 45-degree rotation lands us at root 2 over 2, root 2 over 2. And with tangent, I have to take that sine value and divide it by the cosine value. Thankfully here we've got the same thing on the top and bottom. Since they're both positive, this will end up being a positive 1 for that tangent there. Cosine of 810, again, I'll subtract off that 720. It's like going 2 times around the circle. We're really trying to find the cosine of 90 degrees. Okay, looking at 90, it lands us at the point 0, 1. And cosine is just that x-coordinate, which is 0. Sine of 450, if we subtract 360, we're left with 90. Okay, if we think about the sine of 90, oops, we're still looking at 0, 1, but this time sine, the y-coordinate is 1. And here's a negative 270, so let's add 360 this time. End up with the cosine of 90. 90 degrees rotates us to 0, 1, and just like J, cosine was the x-coordinate 0. Okay, a couple more examples here. Looking at the cosine of negative 1800, we're going to have to add 360 a whole bunch of times. Okay, so if we add 365 times, it lands us to 0. So that was 365 times. We're looking for the cosine of 0. So that 0-degree rotation lands us at the point 1, 0, and cosine is your x-coordinate of 1. Tangent is 780. We're going to have to subtract 2 times around the circle. 720 degrees. We're looking for the tangent of 60 degrees. So 60 degrees lands us at the point 1/2 root 3 over 2. And with tangent, we're going to be showing a lot of work here. So we're going to take our y value, our sine value, and divide it by cosine, or x value. Instead of dividing by a fraction, we multiply by the reciprocal. So on the top, we have 2 root 3. On the bottom, we have 2. 2 divided by 2 gives us 1. So here we just have the square root of 3. And then we've got the cosine of negative 240. Adding 360 to that gives us the cosine of 120. Rotating 120 degrees lands us at the point negative 1/2 root 3 over 2. Cosine is our x value, so we have negative 1/2. And the last one here, the tangent of 1050. Subtract off another 720 2 times around the circle. We're looking at the tangent of 330 degrees. As I can see there, we're at root 3 over 2, negative 1/2. And then I'm going to move this unit circle. We're done looking at that. Let's figure out our tangent here, taking our y-coordinate, sine, dividing it by cosine, the x-coordinate. Instead of dividing by a fraction, we're going to multiply by the reciprocal. On the top, we get -2. On the bottom, we get 2 root 3. -2 divided by 2 gives us -1 over root 3. But we cannot leave that radical on the bottom of the fraction. So we're going to multiply by root 3 over root 3. We're going to rationalize that denominator, end up with -root 3 on the top. And on the bottom, we'd have the square root of 9, which is really just 3.